Ghana Teacher Licensure Exams 2025. Numeracy. So this is a lecture note on area and perimeter of plane shapes. With the plane shapes, we are going to look at rectangle, square, and circle. So let's begin with the concept of area. The concept of area. So what comes in mind anytime we talk about area? So area of a plane shape. When we talk about area of a plane shape, then we are looking at the surface covering of the shape. The surface covering of the shape. So I have with me here a plane shape. So we all know this is a rectangle. This is a rectangle. We all know that this is a rectangle. So when we talk about the area of this rectangle, then we are looking at the surface covering of this rectangle. So this is the surface covering of the rectangle. The surface covering of the rectangle. That is the shaded surface on the rectangle. So anytime we talk about the surface covering of a shape, then we are looking at the concept of area. Now, it also represents the total amount of space inside the shape's boundary. So still using the rectangle as our case study, can you identify the boundaries of this rectangle? You see that this rectangle has 4 boundaries. This is the first boundary, second, third, and then fourth. So these are the boundaries of the rectangle. Do we have a space inside the boundaries? Yes. So this is the space inside the boundaries. And because we are looking at the space inside the boundaries of this plane shape, then we are looking at the concept of area. Now also take note, area is 2-dimensional. So because it is 2-dimensional, it is measured in square units. It is measured in square units. So depending on the unit of measurement, if the dimensions is given in terms of centimeters, then the area of that particular shape will be in centimeters squared. If it is given in terms of meters, then the area will be in meters squared. If the dimensions are given in feet, then the area will be in feet squared. If the dimensions are given in kilometers, then the area will be kilometers squared, etc., etc. So that is the units. Now let's also look at practical examples of the concept of area. In certain questions, you will not be asked to calculate the area, but then they will frame the question in such a way that it should give you an idea that we are looking at the concept of area. So let's go through some of these practical examples. So let's say we are talking about the floor surface of a room. The floor surface of a room. The floor surface of a room. So let's say this is the floor surface of a room in the shape of a rectangle. So we have floor surface of a room. Floor surface of a room. So where is the floor surface? So this is the boundaries. So we are looking at the surface of the floor. So the floor surface of a room talks about the concept of area. Take note. Next, garden space for planting crops. The garden space for planting crops. So let's say we have a garden also in a shape of a rectangle. So this is our garden. This is our garden in the shape of a rectangle. So where is the garden space? So this will be the boundaries of the garden. So this will be the space for planting crops. So the space for planting crops also talks about area of the garden. Next, wall surface to be painted. The wall surface to be painted. In most cases, the wall surface in a room are also in the shape of a rectangle. So let's say this is our wall surface. This is our wall surface. So the painting space, we are looking at the concept of area. So the wall surface that is to be painted, we are looking at the concept of area. Next, we can also talk about the surface of a floor to be carpeted or tiled. So we have a floor also in the shape of a rectangle. So where is the surface of the floor? So this is the surface of the floor where we can lay our carpet or we can tile, So we can decide to tile the floor. We can decide to tile the floor. So the surface of a floor to be tiled or carpeted, we are looking at the concept of area. So these are the tiles, and the tiles are laid on the surface of the floor. So as I said, we are looking at the concept of area. If we also want to carpet the surface of a floor, we are also looking at the concept of area. We can also look at the floor surface of parking lot or a garage. So let's say we have a garage also in the shape of a rectangle. Then the available space for parking our vehicles also talks about the concept of area. So this is the available space for parking. We are also dealing with the concept of area. So you can also add up your own practical examples. Next, let's also look at the concept of perimeter. So anytime you hear about perimeter of a plane shape, then we are looking at the distance around the boundaries of the shape. The distance around the boundaries of the shape. So we still have our rectangle. We know that rectangle has 4 different boundaries. So these are the boundaries. We have 1, we have 2, 3, and then 4. So when we measure the total distance around this particular shape, then we are looking at the concept of perimeter. Now, perimeter is measured in units. So perimeter, because it is distance, it is one dimensional. So it can be measured in centimeters, can be measured in meters, it can be measured in feet, it can be measured in kilometers, it can be measured in inches, etc., etc. Finally, what are some of the practical examples that should give you an idea about the concept of perimeter? So, for example, when you talk about the distance around a playing field, the distance around a playing field, so we have our playing field. So this is our playing field. So when you try to measure the distance around this playing field, then we are looking at the concept of perimeter, the distance around a playing field, the distance around a playing figure, the distance around a garden, the distance around a board. Then we are still looking at the concept of perimeter. We can also look at distance around a picture frame. So let's say we have a picture frame. So this is our picture frame. Picture frame. Picture frame. Once we look at the distance around this picture frame, then we are looking at the concept of perimeter. Distance around a flower bed, we are still looking at the concept of perimeter. So that is for the concept of area and perimeter of plane shapes. So let's begin with the first plane shape. So we have a plane shape here. I hope we can all identify this particular plane shape. We know that this plane shape here is a rectangle. So what makes a plane shape to be called a rectangle? So to answer this, we need to know the properties of a rectangle. Now, the first property that we are all familiar with is that a rectangle has 4 sides. So this rectangle here has 1, 2, 3, 4. So 4 sides. We also know that the opposite sides are equal in length. So for this particular rectangle, first of all, let me name this rectangle as rectangle P Q R S. So can we identify the opposite sides? So we could say that the side PQ or the side PQ, as I said, is opposite the side SR. So because they are opposite each other, and because this is a rectangle, then it means that the opposite sides should have equal length. Meaning that if line PQ measures 8 centimeters, then line SR should also measure 8 centimeters. Can we also identify the other opposite sides? So again, line PS or side PS is opposite line QR. Because they are opposite each other, they will also have the same length. Or yes, they will have the same length or the same measure. You have the same measure. So if line PS measures 5 centimeters, then line QR will also measure 5 centimeters. So that is another property of a rectangle. Opposite sides are equal in length. And again, because it is a four-sided plane figure, it will have 4 interior angles or 4 inner angles. And each of the interior angles measures 90 degrees. So the angle located at point P measures 90 degrees. We have this angle here, 90 degrees. We have this angle, 90 degrees. And then the angle located at point S also measuring 90 degrees. So these are some few properties of a rectangle. But for the sake of this discussion, I want us to focus on only these 3 properties. Next is the area of a rectangle. So the area of a rectangle is given by the formula length multiplied by width, where the length is the longest side of the rectangle and then the shortest side is the width, also known as the breadth. Another name for the width is the breadth. So using this particular rectangle, that is rectangle PQRS as a case study, what is the length of this particular rectangle? So that is the longest side. So the longest side, which is the length, is given as 8 centimeters. The width, that is the shortest side, is given as 5 centimeters. But because we are looking for area, we have to multiply the length and then the width. 8 centimeters multiplied by 5 centimeters, we have 40. 8 times 5 is 40. Remember, we said area is 2-dimensional. And because the dimensions were given in centimeters, the unit will be centimeters squared. So that is the area of a rectangle. Anytime you are asked to calculate the area of a rectangle, all that you need is the length and the width of the rectangle. Just multiply the two to get the area of the rectangle. Next is the perimeter. The perimeter of a rectangle. So with the perimeter, it goes by the formula 2L plus 2W. So we know the length of this rectangle as 8. So we have 2 multiplied by 8 plus 2 multiplied by the width. The width was given as 5 centimeters. We know that 2 times 8, we have 16. 2 times 5, we have 10. So the perimeter will be 26 centimeters. Remember, we said that perimeter talks about the distance around a plane shape or a plane figure. So for this particular rectangle, we know that it has 4 sides. In other words, it has 4 different boundaries. So to calculate the perimeter, we know the length of this boundary, that is boundary PQ, as 8 centimeters. plus the length of this boundary, that is QR, we have 5 centimeters. The length of this boundary, RS, we have 8 centimeters. Then the last boundary, SP, we have 5 centimeters. I want us to verify something. We know that 8 centimeters plus 8 centimeters, that is 16 centimeters. And then 5 centimeters plus 5 centimeters, we have 10 centimeters. And 16 centimeters plus 10 centimeters, we have 26 centimeters. So meaning that the formula is right. Yes, we are right. When we use the formula, we have 26 centimeters. When we use the normal way of calculating the perimeter, that is the distance around the plane shape. In other words, the distance around this rectangle, we also had the same answer. So in conclusion, the area of a rectangle is given by the formula length multiplied by the width of the rectangle. The perimeter of a rectangle is given by the formula 2L plus 2W. Self-assessment. So we have a test on area and perimeter of a rectangle. So in this particular test, there are 8 multiple choice questions that we are going to work through them. Now let's begin with the first question. We are to find the area of a rectangle whose length measures 6 centimeters and whose width measures 4 centimeters. So we have a rectangle. Now the length of this particular rectangle has been given as 6 centimeters and the width is given as 4 centimeters. Remember, we said that to calculate the area of a rectangle, you just have to multiply the length of the rectangle by its width. So we know that the length of this rectangle measures 6 centimeters. Its width measures 4 centimeters. So the area of this rectangle, we have 6 multiplied by 4, and that is 24 centimeters squared. The right answer is option C. Question 2. A rectangular playing field has an area of 3,500 meters squared and a length 100 meters. We are to find the width of the playing field. So we have a playing field in the shape of a rectangle. Now the area of this playing field was given as 3,500 meters squared. So that is the area of the playing field. This area has been given. Again, we were given the dimensions of the length, that is 100 meters. So let's find the width. Remember, we are still looking at area of a rectangle. We know that the area of a rectangle is given as length multiplied by the width. So now let's do substitution. What is the area? The area was given as 3,500 meters squared. We know the length as 100 meters, but we are still looking for the width. So let's simplify. So we have 3,500 being equal to 100 multiplied by W. We have 100 W. But because we are looking for W, we divide both sides by 100. Divide both sides by 100. So 100 will cancel out, leaving 3,500 divided by 100. So let's see the result. 3,500 divided by 100. 35. So we have 35 equal to W. So in conclusion, we can simply say that the width of the playing field measures 35 meters. The right answer is option. Question 3. Say Akon wants to put a new carpet in his living room. The room measures 12 feet by 10 feet. How many square feet of carpet will Say Akon need? So we've been given the dimensions of the floor of his living room. That is 12 feet by 10 feet. This alone should tell us that the floor of his living room is in the shape of a rectangle. So we have the dimensions. The longest side will always be the length. In this case, giving us 12 feet. And then the shortest side will be giving us, or the shortest side represent the width, which is giving us 10 feet. Now he wants to put a new carpet in his living room. So in real life, where do we place a carpet in a living room? So the carpet will be placed on the floor surface. That is the surface of the floor. Surface of the floor. So because we are talking about the surface of the floor, we are looking at the concept of area of the floor of the living room. And since the floor of the living room is in the shape of a rectangle, to calculate the area, you just have to multiply the length and the width. Know the length as 12 feet, the width as 10 feet. So 12 feet multiplied by 10 feet, 120. So we have the area as 120 feet squared. The right answer is option B. Question 4. A painter needs to paint a rectangular ceiling that measures 15 feet by 12 feet. If a can of paint can paint 100 square feet, then how many cans will the painter need? So we have a ceiling in the shape of a rectangle. So that is a rectangular ceiling. Now we were given the dimensions of this particular ceiling. So the longest side, which is the length, was given as 15 feet, and the width, which represents the shortest side, was given as 12 feet. Now this painter wants to paint the ceiling. So where exactly will the painter apply the paint? So the paint will be applied on the surface of the ceiling. So the painter will apply the paint on the surface of the ceiling. And once we are looking at the surface of the ceiling, then one thing should come in mind. That is the area. So let's calculate the area of the rectangular ceiling. So to calculate the area of the rectangular ceiling, we have to multiply the length by the width of the rectangular ceiling. We know that the length is 15 feet and the width is 12 feet. So what is 15 multiplied by 12? So 15 multiplied by 12, we have 180. So 180 feet squared as the area of the entire rectangular ceiling. But we are not looking at the area of the rectangular ceiling, but then we are looking at the number of cans of paint the painter needs to paint the entire rectangular ceiling. But we were told that for every can of paint, that is for every 1 can of paint, the painter can use it to paint an area of 100 feet squared. So for every 1 can of paint, it can paint a total of 100 feet squared. But then the area of this rectangular ceiling measures 180 feet squared, which is more than the 100 feet squared. So it means that the painter will still need an additional can, so making 2 cans of paint. So let's do some analysis. If a can of paint can paint 100 feet square, then it means that 2 cans of paint can paint 200 feet squared. So you could see that the painter will need 2 cans, just that after painting the entire ceiling, there will still be some quantity of paint inside the second can. There will still be an additional paint inside the second can. But one thing is for sure, that is, since the goal of the painter is to paint the entire rectangular ceiling, then it means that he will need 2 cans to complete the painting. So with this, we select option B as our answer. Question 5. The length of a school garden is twice as long as its breadth. If the garden has an area of 72 meters squared, then you have to find the dimensions of the garden. So we have a school garden which is in the shape of a rectangle. So this is a rectangular garden. Now, because it is in the shape of a rectangle, it will have 2 dimensions. The longest side is the length, and then the shortest side is the width or the breadth. So in this particular question, the shortest side was named as the breadth. But then the area of this rectangular garden, was given as 72 meters squared. So what are we looking for? We are looking for the dimensions of the garden, that is the length and the breadth. we are looking at the dimension of the length as well as the dimensions of the breadth. So in this kind of question, we have to apply a little bit of algebra. So we know that in a rectangle, the longest side is the length and the shortest side is the breadth. But then in this particular rectangle, we were not given the actual length of the rectangle as well as the actual breadth of the rectangle. But then we were given the relationship that exists between the length and the breadth. We were told that the length is twice as long as the breadth. So twice in algebra means it's two times as long as the breadth. So if we represent the breadth as A, then the length will measure 2A, because 2 times A, that is 2A. So with this, we can create an equation using the formula for calculating the area of a rectangle. We know that the area of a rectangle is given as the length multiplied by the breadth. So in this rectangle, the length has been represented as 2A and the breadth has been represented as A. But then what is the area? So the area is given as 72. So what is 2A times A? In algebra, 2A multiplied by A, we have 2A squared. So let's solve for A. So to solve for A, first of all, we need to divide both sides by 2. So these two will cancel out. And what is 72 on 2? 72 divided by 2, we have 36. So we have 36 as A squared. So A squared is 36. But we are looking for A. For now, we are looking for the value of A. So to get the value of A, then we have to do away with the square. So how do we do away with the square? So to do away with the square, we have to take the square roots on both sides. In an equation, what you do to the left, you do same to the right. We take the square root on both sides. We are taking the square root because we want to do away with this particular square. So the square root and the square will cancel out, leaving A on the right. And what is square root of 36? Square root of 36, we have 6. So we have 6 is equal to A. Therefore, the value of A is 6. So let's do some substitution. With this, can we tell the breadth of this garden? Initially, we represented the breadth as A. So if the breadth is A and then we had A as 6, then it means that the breadth of this garden will measure 6 meters. Now, how then do we calculate for the length? So for the length, we said the length is twice as long as the breadth, so 2A. So we have the length as 2 multiplying A. You know A as 6. You know A as 6. And then 2 multiplied by 6, that is 12. So 12 meters. So in conclusion, The length of this garden measures 12 meters and the breadth measures 6 meters. So the right answer is option D. Question 6. Ebenezer wants to tile his room, which measures 10 feet by 14 feet. If tiles cost $4 per square foot, then how much will it cost Ebenezer to tile his room? So we've been given the dimensions of his room, that is 10 feet by 14 feet. So this alone should tell us that the room, or in other words, the floor of his room is in the shape of a rectangle. So we know the dimensions. The longest side is the length and the shortest side is the width. So it means that the length will measure 14 feet and the width will measure 10 feet. But his aim here is to tile his room. Tile his room. So where exactly can he apply the tiles? So the tiles can be applied on the surface of the floor. That is the floor surface of his room. That is where he can apply the tiles. And because we are looking at the floor surface of the room, then what comes in mind is the area of the floor surface of his room. So the area of a rectangular floor surface is giving us the length multiplied by the width. So we know that the length is 14 feet, the width is 10 feet. So what is 14 multiplied by 10? 14 feet multiplied by 10 feet. 140 feet squared. 140 feet squared. So that is the area of the floor surface of his room. But then we are not looking at the area of the floor surface, but rather how much it will cost Ebenezer to tile his room. How much it will cost Ebenezer to tile his room. Now, to get the cost, we know that for every square foot, that is for every 1 foot squared of area, that is for a tile, the cost is $4. But this time, the area of the floor surface of his room is 140 feet squared. So if 1 foot squared is giving us $4, then 140 feet squared will give us 140 multiplied by $4. So that will be the cost. 1 foot squared, the cost is $4. That is for 1 foot square of a tile. The cost is $4. But then we want the total cost of 140 foot squared. So that will be 140 foot squared multiplied by $4. So let's see. 140 multiplied by 4. That is $560. So the total cost is $560. The right answer is option C. Question 7. A farmer has a rectangular field that measures 15 meters by 8 meters. So this is our rectangular field with the dimensions 15 meters by 8 meters. So the length will be 15 meters and the width we have 8 meters. So this is our rectangular field. Now if he wants to put a fence around the field, take note, this time the farmer wants to put a fence around the field. So what is the total length of fencing he will need? So where do we place a fence? So the fence will be placed in line with the boundaries of the field. So that is how we do the fencing. So the fencing will be placed along the entire boundary of the field. So in doing so, we are looking at the total distance around the field. The total distance around the field. And we know that the total distance around the field is the perimeter of the field. So the perimeter of the field. We know that since the field is in the shape of a rectangle, we need to use the formula for calculating the perimeter of a rectangle, and that is 2L plus 2W. So let's do our substitution. We know the length of the field as 15 meters. So plus the width, which is 8 meters. So 2 multiplied by 15, this will give us 30. And then 2 multiplied by 8, we have 16. So 30 plus 16, that is 46. So the unit will be in meters, 46 meters. So that is by the formula approach. We can also go by the normal approach. That is the total distance around the field. So this length here measures 15 meters plus this length 8 meters plus this length, which is also 15 meters, plus the final length, which is 8 meters. We know that 15 plus 15, that is 30, and then 8 plus 8, 16. So this one will also give us 46 meters. So still the right answer is option C. That is the total length of the fencing material should be 46 meters long. Question 8. This is the last question under this section. A contractor wants to put a fence around a site that measures 25 meters by 18 meters. So it is clear that the site is in the shape of a rectangle. So this is our rectangular site. We also know the dimensions. The length, which is the longest side, was giving us 12 meters, and the width, the shortest side, was giving us 18 meters. Now this contractor wants to put a fence around the site. He wants to put a fence around the site. So How is the fencing going to be done? So we see that he has to place the fencing in line with the boundaries of the rectangular site. So that is how the fencing could be done. The fencing material has to be placed in line with the boundaries of the site. So we are looking at the total distance around the site. Total distance around the site. The total distance around the site is the perimeter of the site. And because the site is in the shape of a rectangle, we know that the perimeter of a rectangle is given by the formula 2L plus 2W, where L is the length and W is the width of the rectangular site. So let's do our substitution. We know the length as 25. We know the width as 18. So let's see. 2 multiplied by 25, that is 50. And then 2 multiplied by 18, that is 36. So the perimeter of the site will be 86 meters. So that is the total distance around the site, 86 meters. But then we are looking at the cost of the fencing material, or in other words, how much it will cost the contractor to fence the entire site. Remember, we were told that every material of fencing, that is every 1 meter long of the fencing material, comes at a cost of 12 Ghana cedis. So that is the fencing material. So every 1 meter long of the fencing material, the cost is 12 Ghana cedis. But then the entire total distance, or in other words, yes, the perimeter of this rectangular site is 86 meters. So if 1 meter comes at a cost of 12 Ghana cedis, then what will be the cost of fencing 86 meters long site? So that will be 86 multiplied by 12 Ghana cedis. So let's see the results. 86 multiplied by 12 Ghana cedis. We have 1032 Ghana cedis. 1032 Ghana cedis. So that will be the cost of fencing the site. So the correct answer is option D. The next subtopic, area and perimeter of a square. So there is a plane shape nicely drawn here, and I know we can identify this plane shape. So this plane shape here is a square. So what qualifies this plane shape to be a square? So to answer this particular question, we need to know some of the properties of a square. Now, the most common property of a square that we are familiar with is that a square has 4 sides. So this square here has 1, 2, 3, 4. So a square has 4 sides. Another property, all of its sides are equal in length. Another special property of a square is that all of its 4 sides are equal in length. So let me name this square as P Q R S. So because it is a square, then it follows that the side PQ has the same length as the side QR, the same length as the side SR, the same length as the side PS. So let's say the side PQ measures 5 centimeters. Then it means that the side QR will also measure 5 centimeters. The side SR 5 centimeters. The side PS will also have a measure of 5 centimeters. So that is for a square. All of its sides are equal in length. Now, because it has 4 sides, automatically it will have 4 inner angles. In other words, 4 interior angles. And each interior angle measures 90 degrees. So the angle located at point P, that is 90 degrees. The angle at point Q, 90 degrees. The angle at point R, 90 degrees. The angle at point S will also measure 90 degrees. So that is another property of a square. So, but for the sake of this particular lesson, I want us to consider only these 3 properties of a square. Now, the next thing we need to know is to also be able to calculate the area of a square and the perimeter of a square. So, to calculate the area of a square, we simply have to multiply 2 of its length. Because it is a square, we know that all of its sides are equal in length. So when you multiply 2 of its length, then that will give you the area of the square. So using this particular square, we know that the length here is 5 centimeters. So the area of this particular square will be 5 centimeters multiplied by 5 centimeters. And this will give us 5 times 5, that is 25. So the area will be 25 centimeters squared. Now in algebra, L times L is L squared. So another way of calculating the area is to use the formula L squared. Because in algebra, L times L is L squared. So it's either you use L times L or you go by L squared. Let's use L squared and see whether we can get the same answer. We know that the length here measures 5 centimeters. So 5 squared. Let's see. 5 squared on the calculator. That is 25. So the area of this particular square will still be 25 centimeters squared. Now let's also look at the perimeter of a square. So the perimeter of a square is giving us 4L. That is, you have to multiply the length of the square by 4. In this particular square, we saw that the length measures 5 centimeters. And then 4 multiplied by 5, that will give us 20 centimeters as the perimeter. We can still go by simple analysis. We know that perimeter is a total distance around a plane shape. So we are looking at the total distance around this particular square. So the first distance, 5 centimeters, plus 5 centimeters, giving us 10 centimeters, plus another 5 centimeters, and then finally plus another 5 centimeters. That will still give us 20 centimeters. So for a square, the area is giving us L squared and the perimeter is giving us 4L, where L represents the length of the square. Self-assessment on area and perimeter of a square. So in this particular test, there are 11 multiple choice questions, of which we have to answer all of them. So let's begin with the first question. Question 1, we are to find the area of a square with length 5 centimeters. So we have a square and the side length is giving us 5 centimeters. Our goal here is to find the area of the square. We know that area of a square is given by the formula L squared. We know our L as 5, so we have to square 5, and we know that 5 squared is the same as 5 multiplied by itself. So 5 times 5, that is 25. So we have 25 centimeters squared. The right answer is option D. Question 2. We are to find the length of a square garden with area 9 meters squared. So we have a garden in the shape of a square. So that is a square garden. We don't know the length of this particular garden, but we know that the area of this garden measures 9 meters squared. So we are looking for the side length of the garden. Because we know the area of the square garden, we need to use the formula for calculating area of a square. We know that the area of a square is giving us L squared. Now the area was giving us 9 meters squared, so this must be equal to L squared. Remember, we are looking for the side length. In other words, we are looking for L. So what do? We need to do away with the squared. We need to do away with the squared. And to do away with the squared, we need to take the square root on both sides. So we need to take the square root on both sides. So taking the square root of 9, taking the square root of L squared, what happens? So the square root and the square will cancel out. And what is the square root of 9? Square root of 9, we have 3. Square root of 9 is 3. So 3 must be equal to L. Hence, we can conclude that the length of the square garden measures 3 meters. The right answer is option D. Question 3. We are to find the perimeter of a square playing field of length 4.5 meters long. So we have a playing field in the shape of a square. Now the length of each side of the field measures 4.5 meters long. Now our goal here is to find the perimeter of the playing field. So perimeter is giving us 4L. Recall this formula. Where L is the side length of the square. So perimeter is equal to 4 multiplied by 4.5. So we have 18 meters. 18 meters. That is the perimeter of the square playing field. So the right answer is C. Question 4. Find the area of a square park whose perimeter is 96 meters. So we have our square park, but all we know is that the perimeter of this square park, that is the total distance around the square park, is giving us 96 meters. So with this information, we have to find the area of the park. So we don't know the length of this park, but then we know the perimeter of the park. So what is the formula for calculating the perimeter of a square park? So that is 4L. Perimeter of a square park is given by the formula. Perimeter is equal to 4L, where L is the length of each side of the square park. Now the perimeter was given as 96 meters. So this must be equal to 4L. So first of all, let's find the length, because without the length, we cannot calculate the area of the square park. So to calculate the length, we have to divide both sides by 4. So the 4 will cancel out, leaving 96 on 4. So let's see, 96 on 4. We have 24. 24 as L. So we can conclude that the length of each side of the square park measures 24 meters. Now next, now that we know the length of each side of the square park, we should be able to calculate the area of the square park. Remember, the area of a square park is given as L squared, and we know our L as 24. So 24 squared. So what is 24 squared? 24 squared. That is 576. 576 meters squared. So that is the area of this particular square park. We select A as question 5. A square tile has a side which measures 30 centimeters long. What is its area? So we have a tile in the shape of a square. Now each side has a length measuring 30 centimeters. So we are looking for the area of the square tile. So area of the square tile is given as L squared. We know L as 30. So 30 squared. So what is 30 squared? 30 squared. 900. 900. So the area of the square tile is 900 centimeters squared. The right answer is option A. Question 6. The area of a square-shaped garden is 121 meters squared. What is the perimeter of the garden? So we have our square-shaped garden. That is a garden in the shape of a square. Now, the area of this particular garden has been given as 121 meters square. So the shaded area is given as 121 meters square. But we want the perimeter. So before we can calculate the perimeter, the first thing we need is the length of each side of the square garden. So how then do we calculate the length? Since we have been given the area of the square-shaped garden, we can calculate the side length using the area formula. So area of a squared is given as L squared. But then the area of this garden is given as 121. So this must be equal to L squared. Because we are looking for L, what do? We have to do away with the squared by taking the square root on both sides of the equation. So in doing so, the square root and the squared will cancel out, leaving L. And what is the square root of 121? So square root of 121, that is 11. So here is 11. So what it means is that the side length of the square garden measures 11 meters. But remember, we are not looking for the length of the garden, but rather the perimeter of the garden. Recall that the perimeter of a garden, that is a square shaped garden, is given as 4L. So you have perimeter as 4 multiplied by L. L here is the side length. We had 11. And we know that 4 multiplied by 11, that is 44. Hence, the perimeter of the garden measures 44 meters. We select D as our final answer. Question 7. A rectangular plot of land measures 30 meters by 14 meters. A portion of this plot measuring 11 meters by 11 meters is used for the cultivation of rice. We are to find the area of the remaining plot not cultivated. So first of all, we have a rectangular plot of land. So this is the rectangular plot of land. And for this rectangular plot of land, a portion of the plot has been used to cultivate rice. So we have the portion in red. So the portion in red is used to cultivate rice. So this portion is used for rice. So first of all, let's write down the dimensions of the rectangular plot of land. So the rectangular plot of land, we are told that the length measures 30 meters and the width measures 14 meters. And within the rectangular plot of land, we also have another plot of land which is in the shape of a square, because the dimensions are the same, 11 meters by 11 meters. This should tell us that the plot of land for cultivating rice is in the shape of a square. So the side length is giving us 11 meters. So our goal here is to find the remaining plot of land not cultivated, that is in terms of area. So we are looking for the shaded portion of the plot. That is what we are looking for. We are looking for the area of the plot shaded in green. So to do this, first of all, let's calculate the area of the rectangular plot of land. So the area of the rectangular plot, yes, so the area of the rectangular plot, don't have much space. So I'm representing that as AR, the area of the rectangular plot. So the area of the rectangular plot can be calculated using the formula length times the width. So we know the length of the rectangular plot as 30 meters and the width as 14 meters. So the area of the rectangular plot will be 30 multiplied by 14. So we have 420 meters squared. 420 meters squared. So that is the area of the rectangular plot of land. Next, let's also calculate the area of the square plot that is used for cultivating rice. So the area of the square plot, area of the square plot. So I'm representing that as A subscript S. That is the area of the square plot. So area of the square plot can be calculated using the formula L squared. So we know that L is the length of the squared. So it was giving us 11. So we have 11 squared. So the area of the square plot, let's see, 11 squared, 121. So 121 meters squared. So that is the area of the square plot that was used to cultivate rice. But then we are looking at the area of the remaining plot of land. So to calculate the area of the remaining plot of land, what do we do? Area of the remaining plot of land. So area of the remaining plot of land. So to calculate the area of the remaining plot of land, that will be the difference between the two areas. That is the area of the rectangular plot of land. So the area of the rectangular plot of land, we had 420 meters squared minus the area of the rice plot, we had 121 meters squared. So finally, the area of the remaining plot of land, 420 meters squared minus 121 meters squared. So that is 299 meters squared. So that is the area of the remaining plot of land not cultivated. So we select D as question 8. Two classrooms A and B have the same floor area. So we have the two classrooms. So the first one, we are naming it as classroom A. The second one, classroom B. So the floor area of classroom A is the same as the floor area of classroom B. Now for classroom A, the dimensions are 8 meters by 6 meters. So the length of classroom A, that will be 8 meters. The width will be 6 meters. Now, if the length of the floor of classroom B is 10 meters, so for classroom B, the length, that is the longest side, we have 10 meters. Then we have to find the width of classroom B. So we don't know the width. So these are the dimensions of classroom A and then classroom B. For classroom A, the length is 8 meters, the width is 6 meters. For classroom B, the length is 10 meters. We don't know the width. But there is a unique relationship between the floor area of classroom A and that of classroom B. That is, the floor area of classroom A is the same as the floor area of classroom B. So first of all, let's calculate the floor area of classroom A. So the floor area of classroom A, I'm representing that as A subscript A. The floor area of classroom A. So because the floor area of classroom A is in the shape of a rectangle, then it means that the area of classroom A will be equal to the length multiplied by the width. So the area of classroom A, we have 8 meters multiplied by 6 meters. So what is 8 meters multiplied by 6 meters? 8 meters multiplied by 6 meters that is 48 meters squared. That is the floor area of classroom A. Let's also calculate the floor area of classroom B. So the floor area of classroom B, that is A subscript B, remember classroom B is also in a shape of a rectangle. So to calculate the floor area of classroom B, we have to multiply the length by the width. And we know that the length of classroom B is 10 meters, but the width, it is unknown. So what is 10 multiplied by W? So we have 10 W. But then, what is the relationship between the floor area of classroom A and the floor area of classroom B? We know that the floor area of classroom A is the same as the floor area of classroom B. For the floor area of classroom A, we had 48 meters squared, and the floor area of classroom B, we had 10 W. Because we are looking for W, we divide both sides by 10. Here by 10. So 10 will cancel out 10. So we are left with 48 divided by 10. And that is, I want the decimal form, 4.8. So we have 4.8 as W. So we can conclude that the width of the floor of classroom B measures 4.8 meters. So we select B as question 9. The length of a rectangular playing field is 10 meters longer than its width. If the perimeter of the field is 180 meters, then we are to find the width of the field. So we have a rectangular playing field. Because the playing field is in the shape of a rectangle, it will surely have two dimensions. We know that the longest side is the length and the shortest side is the width. But we were not given the actual measures of the length and the width. But then they gave us the relationship that exists between the length and the width. So we are told that the length of the rectangular playing field is 10 meters longer than its width. So if the width is represented as A, then 10 meters longer than A, that is A plus 10. Let me explain this. This is algebra. Let's say we have a rope. We have a rope. So this is a rope. And then we know that the length of the rope is, let's say, 5 meters. So if we are asked to find the length of a rope, that would be 2 meters longer than 5 meters. I'm taking it again. We have a rope that measures 5 meters long. Now we want another rope, but then this rope should have a length that is 2 meters longer than the original rope. So what should be the new length of the new rope? So that will be 7 meters, because we are looking for a rope whose length is 2 meters longer than the 5 meters. So obviously that is 7 meters long rope. So how do we get the 7 meters? Because we are looking for a rope that is 2 meters longer than 5 meters. We just have to add 2 meters to 5 meters. We add 2 meters to 5 meters, and that gave us the 7 meters. So that is how we got A plus 10. So if the original rope measures A meters long, then it means that when we are looking for a rope which is 10 meters longer than A, that would be A plus 10. Now that we know the expressions for the length and the width of the rectangular playing field, we should be able to calculate the width, knowing that the perimeter of the entire playing field measures 180 meters. So we know that the perimeter of a rectangular playing field is given by the formula 2L plus 2W. But then the perimeter of this field was given as 180. So this must be equal to 2 multiplied by the expression for the length. We have A plus 10 plus 2W. And we know that the expression for W is A. So let's work it out. Let's expand the first bracket. 2 multiplied by A, we have 2A. 2 multiplied by 10, we have 20. 2 multiplied by A, we have 2A. We can still simplify. 2A plus 2A, that is 4A, then plus 20. So we are grouping like terms, numbers on the left, variables on the right. So 180 minus 20. So bringing positive 20 to the left becomes minus 20, and this must be equal to 4A. 180 minus 20. 180 minus 20, that is 160. And this must be equal to 4A. So since we are looking for A, we have to divide both sides by 4. So 4 will cancel out, leaving A on the right. And what is 160 divided by 4? So that is 40. So we have 40 equal to A. Hence, A will be 40 meters. But we are supposed to find the length of the width. And remember, we represented the length of the width as A. Therefore, the width of the playing field measures 40 meters. So C is the answer. Question 10. A gardener wants to put a fence around his square garden with an area of 36 meters squared. If the fencing material costs 11 Ghana cedis per meter, then how much will it cost the gardener to fence his garden? So we have a square garden. And then with this particular square garden, you are told that the area of the square garden measures 36 meters squared. But then this gardener wants to put a fence around the garden. So he wants to put a fence around the garden. So how will the fencing be done? So he has to place the fencing material in line with the boundaries of the garden. So the boundaries of the garden, we are looking at the total distance around the square garden. And the total distance around the square garden also refers to the perimeter of the square garden. And we know that to calculate the perimeter of a square, we go by the formula perimeter is equal to 4L, where L is the length of each side of the rectangle. So even before we can calculate the perimeter, we need the length of each side of the garden. But because we know the area of the garden, we should first of all use the area formula to find the length of the garden. Remember that the area of a square garden is given by the formula L squared. So let's do our substitution. The area was given as 36 meters squared. So this must be equal to L squared. And because we are looking for L, we need to do away with the square by taking the square root on both sides. So the square root and the square will cancel out, leaving L on the right. So let's find out the square root of 36. Square root of 36, we have 6. So 6 is equal to L. Therefore, L is equal to 6 meters, meaning that the side length of the square garden measures 6 meters. Now that we know the length of the square garden, we should be able to calculate the perimeter of the square garden. So the perimeter of the square garden is given by the formula 4L. So 4 multiplied by 6. We know that the total distance around the garden is 24 meters. So he will need 24 meters long of the fencing material. So the cost will be 24 multiplied by 11 Ghana cedis. So if 1 meter long, the cost is 11 Ghana cedis. Then for 24 meters long, the cost will be 24 multiplied by 11 Ghana cedis. So 24 multiplied by 11 Ghana cedis, that is 264 Ghana cedis. 264 Ghana cedis. So this is how much it will cost the gardener to fence around the square garden. We select option B. Question 11. So this is the last question under this particular test. We are to calculate the cost of tiling a square room of size 5 meters if every 1 by 1 meter square of tile costs 12 cedis, 44 pesos. So we have our square room. We know the dimension of the square room. So the length of each side of the square room measures 5 meters. Now, our aim here is to find the cost of tiling this room. So how do we tile this room? So we know that to tile the room, the tiling will be done on the floor surface of the room. The floor surface of the room. And we know that the floor surface of the room, we are looking at the area of the floor surface of a room. And the area of a square surface of a room is giving us L squared. And we know that L here is the length, which is giving us 5. So we have 5 squared. So area of the square room will be 25 meters squared. So that is the area of this particular square room. But again, we are looking at the cost of tiling this square room. Now we know that for every 1 meter square of tile, the cost is 12 cedis, 44 pesos. But then the total area of this square room is 25 meters square. So if every 1 meter square of tile, the cost is 12 cedis, 44 pesos, then for an area of 25 meters squared, the cost of tiling will be 25 multiplied by 12 cedis, 44 pesos. So let's see. 25 multiplied by 12 cedis, 44 pesos. So that is 311 Ghana cedis. 311 Ghana cedis. So that will be the cost of tiling this particular square room. So we select A as the final answer. The next subtopic, that is the area and perimeter of a circle. So we have this plane shape. We all know that this is a circle. This is a circle. And this circle has a central point. It has a central point. I'm naming the central point as O. So because O is a central point, it also means that O is the center of this particular circle. Now, in a circle, the total distance around the circle, that is the total distance around a circle, is what we call the circumference of a circle. In other words, the perimeter of any circle, that is the total distance around the circle, is called the circumference of a circle. Now, inside the circle, I have a particular line, but then this line connects the center of the circle to a point on the circumference. Now, I'm naming this point here as point R. So in this particular circle, we can see that line OR, talking about this line, the line that connects the center to the point R on the circumference, is the radius of a circle. So the radius of a circle is a straight line that connects the center to any point on the circumference of a circle. Inside the circle, I also have a red line. And you can see that this red line divides the circle into two equal parts. Again, this straight line passes through the center of the circle and also touches 2 points on the circumference. So I'm naming here the first point here as point M, and then the other point as N. So you can say that from the circle, line MN is a diameter. So any straight line that divides the circle into two equal parts is called the diameter of a circle. So there are so many parts of a circle, but for the sake of this particular lesson, I want us to consider these few: the radius, the circumference, and the diameter of a circle. Since we are looking at area and perimeter, we also need to know the formula for calculating the area of a given circle. So the area of a circle is given by the formula pi r squared, where r is the radius of the circle. Take note, the area of a circle is given by the formula pi r squared, where r is the radius of the circle. Now, the value of pi will be given in the question. Sometimes the value of pi is given as 22/7. Sometimes it is given as 3.14. Other times 3.142, etc., etc. So the value of pi will be given in the question. But this is the formula for calculating the area of a circle, pi r squared. To also calculate the perimeter of a circle, that is the total distance around the circle, the formula is 2 pi r. 2 pi r. That is the circumference or the perimeter or the total distance around the circle. The formula is 2 pi r. Again, r is the radius of the circle. And as I said, the value of pi will be given in the question. So take note, the circumference of a circle is also the same as the perimeter of a circle. The total distance around the circle is the circumference of the circle or the perimeter of the circle. Self-assessment on area and perimeter of a circle. So in this particular test, we have 6 multiple choice questions that we are going to work through them. Question 1. We are to calculate the area of a circle with radius measuring 7 centimeters. So we have our circle, this is our center, and this is our radius. Remember, we said the radius is a straight line that connects the center to any point on the circumference. So the radius of this circle measures 7 centimeters. We are looking for the area. We said the area of a circle is given by the formula pi r squared. Pi r squared, where r is the radius of the circle. And then I also said that the value of pi will always be given in the question. So let's do our substitution. So we have area being equal to pi. We are asked to take pi as 22 on 7. So in place of pi, substitute 22 on 7 multiply by r squared. So r is the radius, so 7 squared. So let's verify our final answer from the calculator. So we have 22 on 7 multiplying 7 squared. So we have 154 centimeters squared as the area of this particular circle. So the answer is option C. Question 2. We are to calculate the perimeter of a circular plot of land with radius of 14 meters. So we have a land in the shape of a circle. So that is our circular plot of land. So this is our center, and this line here will be our radius. So the radius is giving us 14 meters. So r, we have 14 meters. Our goal is to calculate the perimeter. So the perimeter is the total distance around the circular plot. Remember, we said perimeter of a circle is the same as the circumference of a circle. The circumference of a circle is given by the formula 2 pi r, where r is the radius of the circle. So we have 2 multiplied by pi. We were asked to take pi as 22 on 7. Then this multiplied by the radius, which is 14 meters long. So finally, let's verify our answer. 2 multiplied by 22 on 7 multiplied by 14. So that is 88 meters. 88 meters. So that is the perimeter of the circular plot. So option D is the right. Question 3. A circular swimming pool has a circumference of 132 meters. What is its radius? So we have a swimming pool in the shape of a circle. Also, this is our center. This line here will be our radius. Remember, for this particular swimming pool, we don't know the measure of the radius, but we were given the circumference of the swimming pool. When we talk about the circumference of the swimming pool, we are looking at the total distance around the swimming pool. Total distance around the circular swimming pool. And we know that the circumference of a circle is giving us 2 pi r. 2 pi r. Because we are looking for the radius, we have to do substitution. The circumference of the circular swimming pool was given as 132 meters. This must be equal to 2 multiplied by pi. Pi was given as 2217, then multiply by r. We don't know the value of r, so we multiply by r. So let's simplify. We have 132 being equal to we have 2 multiplied by 22 on 7. Let's see the result. 2 multiplied by 22 on 7. So that is 44 on 7. So 2 multiplied by 22 on 7 multiplied by r. That will give us 44 on 7r. Remember, we are looking for r. So what do we do? So we have to divide both sides by 44 on 7. So on the left we have 132. On the right we have 44 on 7r. So because we are looking for r, we divide both sides by 44 on 7. Divide here by 44 on 7. So 44 on 7, 44 on 7 will cancel out, leaving r on the right. So what is 132 divided by 44 on 7? So let's see. 132. So we are going to enter it this way. 132 divided by 44 on 7. So that is 21. So we have 21 equal to r. Therefore, the radius of the circular swimming pool measures 21 meters. So the right answer is option C. Question 4. A circular pizza has a diameter of 30 centimeters. What is the area of the pizza? So we have our circular pizza. Circular pizza is a pizza in the shape of a circle. This is our center. This is our diameter. We know that the diameter of this pizza is 30 centimeters. But our goal here is to find the area of the circular pizza. And because the pizza is in the shape of a circle, to calculate its area, we go by the formula pi r squared. We know the value of pi as 3.14. What is missing here is the radius. So let's find the radius of this particular circular pizza. Now, from the circle or from the pizza, we know that the diameter is 30 centimeters. And we saw that the radius of a circle is a straight line that connects the center to a point on the circumference. So we can say that the distance from the center to this particular point is the radius of the circular pizza. And again, when you take a closer look at the pizza, you can see that the radius is half the diameter. That is, when you divide the diameter by 2, you get the radius. So to calculate for the radius will be half the diameter. And we know that the diameter of this particular circular pizza measures 30 centimeters. So what is half of 30? Half of 30 is the same as 30 divided by 2, and this will give us 15 centimeters. So the radius of this circular pizza measures 15 centimeters. Now with this, we can do our substitution. We know that pi is 3.14 multiplied by the radius, which is 15, all squared. So let's see our final result from the calculator. 3.14 multiplied by 15 all squared. So looking at the alternatives, it was given in the form of decimal. So let's change this to decimal by pressing the SD button. So we have 706.5. So the area of the circular pizza is 706.5. And again, you can see that the alternatives have been corrected to 2 decimal places. So we just add 10, and the unit will be in centimeters squared. So we select option A. Question 5. A goat is tied to a pole with a 1.5 meters long rope. The goat moves, keeping the rope tight. We are to find the area of grass available for the goat to graze. We are also to correct our answer to the nearest whole number. So let's demonstrate this with a diagram. So we have a pole, and then this is the level ground. Now we have a goat. We have a goat, and this goat here has been tied with a rope. So we have a rope. We have a rope. We know that the length of the rope is 1.5 meters long. 1.5 meters long. Now this goat here keeps on moving, and in the process of moving, it is trying to escape. So as it is trying to escape, it keeps the rope very tight. The rope will be very straight and then tight to its neck. So this goat here will be moving in a circular pattern because the rope is stretched to the limit. Its movement will always be in a form of a circle. So at any point in time, the rope is stretched or tightened to its neck. So this is the maximum distance it can move. So always the length of the rope from the pole will always be 1.5 meters. And if that is the case, then it means that the goat will be moving in a circular pattern. So this will be the area of grass available. So the space inside the circular pattern will be the grass available for the goat to graze. So to simplify this, its movement will give rise to a circle, whose radius will always measure 1.5 meters. So because we are looking at the area of grass available, we go by the formula pi r squared. So we were given the value of pi as 22 on 7. This multiplying the radius 1.5 squared. So what is the area? What is the area? So let's see from the calculator. The area, we have 22 on 7 multiplying 1.5 all squared. So in the decimal form we have, so for now let's correct it to 2 decimal places. We have 7.07, 7.07, and remember we were asked to correct our answer to the nearest whole number. So to the nearest whole number, that is 7 meters squared. So the area of grass that will be available for the goat to graze will be 7.7 meters squared. 7 meters squared. So the right answer is option B. Question 6. A dump truck wheel has a radius of 0.7 meters. What distance will it cover in 50 rotations? So we know that a dump truck wheel will always be circular in shape. So that is a dump truck wheel. Now we know the radius of the wheel as 0.7 meters. So R is equal to 0.7 meters. Now we are looking at the distance this wheel will cover in 50 rotations. So first of all, let's calculate the distance the wheel will cover in one rotation. So when we talk about one complete rotation, we are looking at a situation whereby each portion of the wheel touches the ground. So let's say this is the starting point. This is the starting point. So we are looking at a situation whereby the wheel will be moving such that this particular point will move in this direction and come back to the starting point. So let's see the movement. Let's say this is the starting point of the wheel. So as the wheel is moving, we see that this starting point will also be moving in this direction. So it will be moving in line with the total distance around the wheel and then come back to the starting point. So that will be one rotation. So what comes in mind looking at the pattern of movement? So we are looking at the total distance around the wheel, the total distance around the wheel, and the total distance around the wheel refers to the perimeter of the circular wheel. In other words, the circumference of the dump truck wheel. And because the wheel is in the form of a circle, the circumference is given by the formula 2 pi r. So we have 2 multiplied by pi. Pi is giving us 22/7 multiplied by the radius, which is giving us 0.7. So let's see. 2 multiplied by 22/7 multiplied by 0.7. So the decimal point, we have 4.4 meters. 4.4 meters. So in one rotation, the total distance covered will be 4.4 meters. But we are looking at the total distance it will cover in 50 rotations. In 50 rotations. So in 50 rotations, so if one rotation covers 4.4 meters, then in 50 rotations, what will be the distance? So the distance will be 50 multiplied by 4.4 meters. So 50 multiplied by 4.4 meters. We have 220 meters. 220 meters. So the right answer is option C. So let's also look at other set of questions concerning area and perimeter of plane shapes. So question 1. 3 pieces of sticks measuring 0.5 meters, 1.2 meters, and 1.3 meters were used to form the sides of a triangular flower bed. We are to calculate the perimeter of the flower bed. So we have a flower bed which is in the shape of a triangle. Now these are the dimensions. So this side has been represented as 0.5 meters. This side 1.2 meters. And then this side 1.3 meters. Remember, we are to calculate the perimeter of the flower bed. So with perimeter, we are looking at the total distance around the flower bed. So which is the perimeter. So we have 0.5 meters plus 1.2 meters plus 1.3 meters. So the perimeter of the flower bed, we have 0.5 meters plus 1.2 meters plus 1.3 meters. So that is 3 meters. 3 meters. The right answer is option A. Question 2. What is the area of triangle ABC in the diagram below, given that the base measures 40 meters long and the perpendicular height is 75 meters? So we have this triangle That is triangle ABC. In this particular triangle, the base measures 40 meters and the perpendicular height measures 75 meters. So we know that the area of a triangle is giving us half multiplied by the base multiplied by the perpendicular height. So with this, let's do the substitution. So we have half. We know the base measures 40 meters long and the perpendicular height is giving us 75 meters. So we have the area of triangle ABC as half, so 1 on 2 multiplied by 40 multiplied by 75. So that is 1,500 meters squared. So the right answer is option B.